to be looking at the ionoform test. The first thing that we're going to be talking about is the condition for the ionoform test. So in this case, the carbon that I've highlighted right now, the one that's directly bonded to the OH, needs to be bonded to a methyl group as well as a hydrogen for this test to be positive. Let's look at a few examples. So in this case, the carbon that I've highlighted over here is the one that's bonded to an OH group. It's also bonded to a hydrogen and a methyl group. So over here, you're going to get a positive ionoform test. Now let's look at another example. Over here, the carbon that I've highlighted is bonded to the OH group, an H group, but there's no methyl groups. You only have two ethyl groups over here. So in this case, you're going to have a negative ionoform test. Now let's look at the equation for this reaction. So in this case, you're going to have your alcohol. It's going to react with iodine and aqueous NaOH, and the condition for this is that it has to be at RTP, and you're going to get ionoform. And this is going to give you a yellow precipitate. You're also going to get sodium iodide, and you're going to get the salt over here and water. Now what's going to happen is that the methyl group that I'm highlighting over here is going to be used to form ionoform, and that's how you're going to get the yellow precipitate. So this was the ionoform test. Polyhydric alcohols are the ones that have more than one OH group. So in this case, we have monohydric alcohols that have one OH, trihydric alcohols that have three OH groups, and dihydric alcohols that have two OH groups. Now let's move on to biofuels. So biofuels are basically an alternative to fossil fuels, and they're going to be produced from plants, which is going to make them renewable. So in this case, the carbon dioxide that is absorbed in photosynthesis is going to be equal to the carbon dioxide that is produced by these biofuels. So this way, it's better for the environment.